Hello students, welcome to Diksha Karnataka YouTube channel. In this video, I'm going to discuss the solution of the mock test to physics part 2 question number 31 to 60. Okay, so if you haven't downloaded the question paper, please join the WhatsApp channel which is given in the description box. In there, you will get the question paper and detailed solution. Okay, yeah, let us start. Question number 31. If a long straight wire carries a current of 40 ampere, okay, long straight wire carries a current of 40 ampere, I equal to 40 ampere, then the magnitude of the field B at point 15 centimeter away from the wire is. Okay, so this is the long wire. Okay, so this is the point where we need to find the magnetic field. The distance between the point and the wire is 15 centimeter. This is the point P where we need to find the magnetic field. So what is the magnetic field due to the long wire at point P? So that will be B equal to mu naught I divided by 2 pi r. Mu naught I divided by 2 pi r. So now B equal to mu naught by 4 pi is 10 to the power minus 7, right? So mu naught by 2 pi is 2 into 10 to the power minus 7. Okay. So now 2 into 10 to the power minus 7 into I. I is here 40 ampere. 40 divided by r. R is 15 centimeter, right? That is 15 into 10 to the power minus 2 meter. So now solve this. You will get B equal to 5.34 into 10 to the power minus 5 Tesla. So the correct option is A. Next question. Question number 32. A metal surface ejects electrons when hit by a green light, but none when hit by yellow light. The electrons will be ejected when the surface is hit by. Okay, when the surface is hit by which of the following rays or light, right? Okay. Here, when will electron emit from the metallic surface? When the energy of the incident light is greater than the work function of the metal, right? So when green light falls on the metallic surface, what happens? Electron will emit, right? But none will emit when hit by yellow light, right? So that is here the lambda, that is wavelength of the yellow light, is greater than wavelength of the green light, right? So energy of the incident light must be greater than work function of the metal, right? So therefore, lambda of yellow light is greater than lambda of green light, right? So we need to find which of the following light, okay, which of the following light when falls on the metallic surface, the electron will emit, okay, yeah. So here, lambda of blue light, you know Vibgyor, right? Vibgyor, so 7 colors, right? So it is in the increasing order, wavelength is in the increasing order, right? So lambda of blue light, right? Lambda of blue light is greater than lambda of heat rays, infrared rays, and red light, right? Lambda of blue light is greater than lambda of heat rays, infrared ray, light, and red light, isn't it? So therefore, electron will emit when blue light falls on the metallic surface. So the correct option is A. Okay, lambda of B is greater than lambda of heat rays, lambda of infrared rays, and lambda of red light, right? So option A is the correct answer. Next question, question number 33. The work function of the cesium is 2.14 electron volt. The threshold frequency of the cesium. Okay, we need to find threshold frequency of the cesium, right? Yeah. So we know that work function phi is equal to hc by lambda. Hc by lambda, or h into nu naught. Hc by lambda naught. Lambda naught is threshold wavelength. Okay, or work function phi equal to h into nu naught. Nu naught is threshold frequency. So threshold frequency nu naught is equal to phi, that is 2.14 into 10 to the power minus 19, okay, into 1.6 divided by h. H is Planck's constant, 6.63 into 10 to the power minus 34. Okay, So now solve this, you will get 5.16 into 10 to the power minus 14. Minus 14 hertz, right? Sorry, 10 to the power plus 14 hertz, not minus 14 hertz, plus 14 hertz. So the correct option is D. Next question, question number 34. An alpha particle and a proton are accelerated through the same potential difference. The ratio of linear momenta acquired by both. Okay, we need to find ratio of linear momenta acquired by both, that is alpha particle and the proton, right? So we know that the kinetic energy is equal to square of the momentum divided by 2m, right? M is mass of the particle. So now momentum, that is linear momentum, is equal to 2m into k. 2m into k, right? So now we need to find the ratio of the linear momentum of the alpha particle to the linear momentum of the proton. So which is equal to, anyway, here 2 will get cancelled, right? So root of m alpha into k, right? M alpha into k. Here k is the kinetic energy, isn't it? So when the particle accelerated through a potential difference, what happens? Kinetic energy of the particle increases, potential energy decreases, electric potential energy decreases. So gain in kinetic energy is equal to loss of potential energy, right? So now I can write kinetic energy as k equal to q into v, right? Q into v. V is potential difference. Q alpha into v divided by mp into qp into v. V will get cancelled, right? So now p alpha divided by p of proton is equal to root of mass of the alpha particle is 4 times mass of the proton. So 4 mp into charge of the alpha particle is 2 times charge of the proton, whole divided by mp into qp. mp into qp will get cancelled. 4 into 2 is 8. So finally p alpha is to p of proton is equal to root 8 is to 1. The correct option is D. Next question, question number 35. A circular coil of 25 turns and radius 12 centimeter is placed in a uniform magnetic field of 0.5 Tesla normal to the plane of the coil. If the current in the coil is 6 ampere, then the total torque acting on the coil. So now the total torque acting on the coil, tau equal to m into b sin theta. So what is m? Magnetic moment. What is b? Magnetic field. Okay, theta is angle between m and b, right? Here, what is the direction of the m, right? So the direction of the m is same as direction of the b, right? So how? So this is the coil, right? So this is the direction of the current, right? Sorry, this is the direction of the current. This is the direction of the current, right? Direction of the current. So angle between m and b, right? So if you apply right hand thumb rule, right? So the angle between m and b is 90 degree, right? Angle between m and b is 90 degree. That is magnetic moment and magnetic field is 90 degree. So therefore, tau equal to m into b. Tau equal to m into b. Okay. In any direction, yeah. Okay, tau equal to m into b. So now tau equal to n IA into b. M is magnetic moment. Magnetic moment is number of turns into current into area of the coil into magnetic field. So now tau equal to n is 25 turns into I is 6 ampere into A is pi into r square, that is pi into 1.44 into 10 to the power minus 4, okay, into B. B is 0.5 Tesla. So now solve this, you will get 3.4 Newton meter. 3.4 Newton meter. So the correct option is D. Okay. Next question, question number 36. if this current sensitivity of a galvanometer is doubled, then its voltage sensitivity will be. Okay. So we know that voltage sensitivity Vs equal to deflection in the galvanometer divided by applied voltage, right? So now Vs is equal to theta divided by I into R. V is I into R, right? So now theta by I is current sensitivity. So Vs equal to Is divided by R, right? We know that current sensitivity Is is equal to NAB divided by C. What is C? C is restoring couple per unit twist, right? So now if current sensitivity is doubled, then the number of turns will also be doubled, right? That is, the length of the wire will increases, right? If the length of the wire increases, what happens? Resistance will also be increases. So if the current sensitivity doubled, resistance will also be doubled, right? So now Vs is equal to 2Is divided by 2R. Finally, Vs equal to Is divided by R. That is, voltage sensitivity remains same. So option C is the correct answer. Okay. Next question. Question number 37. A susceptibility of a certain magnet material is 400. What is the class of the magnet material? Here, susceptibility of the material, magnet material is 400. That is, susceptibility of the material is much greater than 1. Right? So, this is the case for ferromagnet. Right? Ferromagnet. Isn't it? So, the material is ferromagnetic. So, the correct option is C. Question number 38. The angular speed of the electron in the nth orbit of Bohr hydrogen atom is. Okay. So if you know the formulas, then you can easily answer this question. Okay. Otherwise, you have to derive it. Okay. So how do you derive? Here, the electron is revolving around the nucleus, right? So here, the angular momentum of the electron in the nth orbit is in the Bohr hydrogen atom or Bohr hydrogen like atom, right? Angular momentum of the electron is mvr, which is equal to nh by 2 pi. nh by 2 pi, right? So now v equal to nh divided by 2 pi into m into r, right? Okay, now we have the velocity of the electron or speed of the electron in the nth orbit, right? So now here electron is revolving around the nucleus. So there is an electrostatic force between the electron and nucleus, right? So the electrostatic force provides the centripetal force, right? So now centripetal force mv square divided by r is equal to k is 1 by 4 pi epsilon naught. Okay, 1 divided by 4 pi epsilon naught into z into e square divided by r square. Z is 1 for hydrogen atom, right? So now r will get cancelled, right? So now substitute the expression of V2 here, right? So from that we will get Rn or R is equal to n square h square. Okay, R is equal to n square h square. Okay, solve. So now substitute V2 this equation, right? M into n square h square divided by 2 pi whole square, right? 2 pi whole square into m square into r square, right? So which is equal to 1 divided by 4 pi epsilon naught into z e square. Z is 1 for hydrogen, right? So e square divided by r. So now r will get cancelled, right? So now we need to find here r, right? So r is equal to 4 pi and 4 pi will get cancelled, right? 4 pi and 4 pi will get cancelled, right? So now m will also get cancelled, right? So r equal to n square h square epsilon naught divided by m into e square. M into e square into z. Okay, z is 1 for hydrogen atom, right? So r is directly proportional to n square. R is directly proportional to N square, right? So now substitute the expression of R to this equation. Okay. So from that you will get V is directly proportional to 1 by N. So they are asking angular speed of the electron. So angular speed omega is equal to V divided by R, right? So now angular speed omega, V is directly proportional to 1 by N, okay, and R is directly proportional to N square. So omega is directly proportional to 1 divided by N cube, or inversely proportional to N cube. So the correct option is D. Next question, question number 39. The radius of the nth orbit, Rn, in terms of Bohr radius A0 for a hydrogen atom is given by the relation. Okay, so here we have derived this one, right? R equal to n square h square epsilon naught divided by m into e square. So R is equal to n square, or Rn. Rn is the radius of the nth orbit, right? Rn equal to n square h square epsilon naught divided by pi, right? Pi. Okay, I forgot to write pi, right? Okay, pi m into e square. Pi m into e square, right? So h square epsilon naught divided by pi m into e square is constant. So that is the Bohr radius, right? So Rn is equal to n square into a naught. A naught is the Bohr radius. So Rn equal to n square into a naught. So the correct option is C. Question number 40. Two nuclei have their mass numbers in the ratio 1:3. The ratio of the nuclear densities would be. Okay, so here the nuclear density of every nucleus is same. Okay, almost same. Okay, so therefore it will be 1:1. That's it. So it will be 1:1. So the correct option is B. Next question, question number 41. If the total binding energies of the deuterium, helium, iron, and uranium 235 are 2.22, 28.3, 492, and 1786 mega electron volt respectively, identify the most stable nucleus of the following. Okay, so we know that stability of the nucleus depends on binding energy per nucleon. Right? The nucleon for deuterium, helium, iron, and uranium 235 is 2, 4, 56, and 235. Right? So find the binding energy per nucleon of each nucleus. Okay, binding energy per nucleon. Find binding energy per nucleon for each nucleus. Okay, find binding energy per nucleon of each nucleus for each nucleus. Okay, so then you will get the maximum value for iron. Okay, binding energy per nucleon for iron is 8.78 mega electron. This is the highest. Okay, so the correct option is A. This is the most stable nucleus. Next question, question number 42. If a coil 40 turns and area 4 centimeter square suddenly removed from the magnetic field, it is observed that charge of 2 into 10 to the power minus 4 coulomb flows into the coil. If resistance of the coil is 80 ohm, the magnetic flux density in Weber per meter square. That is, we need to find the value of B, right? That is the magnetic flux density. Yeah. So here, induced current, when the coil suddenly removed from the magnetic field, what happens? Induced current will be produced in the coil, right? So now induced current in the coil is equal to induced EMF produced in the coil divided by resistance of the coil, right? So now induced current I is equal to induced EMF is change in magnetic flux over change in time into N. N is the number of turns. Okay, divided by resistance R. So now I into delta T is equal to N into delta phi divided by R. So what is delta T into I? That is current into change in time, which is equal to the charge, right? So charge delta Q is equal to N into delta phi divided by R. So what is delta phi? Change in magnetic flux, right? So now delta Q is equal to delta Q is equal to N into B into A. Change in magnetic flux is B into A cos theta. Theta is angle between B and A, that is 0 degree. So it is just B into A divided by R. We need to find the value of B. So B equal to delta Q into R divided by N into A. So now substitute the values. Okay. Substitute the values. Here B equal to delta Q, that is 2 into 10 to the power minus 4 into R. R is 80 ohm divided by N is 40 turns into area is 4 centimeter square, that is 4 into 10 to the power minus 4. So now solve this, you will get B equal to 1 Weber per meter square. So the correct option is B. Next question, question number 43. An air-cooled solenoid with length 20 centimeter, L equal to 20 into 10 to the power minus 2. Area of cross section 20 centimeter square, that is 20 into 10 to the power minus 4. 20 into 10 to the power minus 4. And number of turns 400. N equal to number of turns, that is 400. Carries a current I equal to 2 ampere. The current is suddenly switched off within 10 to the power minus 3 seconds. That is I2 is equal to 0. I1 is equal to 2 ampere. Okay. So now the change in current is in negative. Okay. Change in current is in negative. That is Di is equal to minus 2 ampere. Okay. Change in current is in negative. The average back EMF induced across the ends of the open switch in the circuit is. Okay, now average induced EMF E is equal to your rate of change of magnetic flux, right? That is minus N into d phi by dt, right? Minus N into d phi by dt, right? Okay, so now here or minus d phi by dt, okay? Minus d phi by dt, yeah, minus d phi by dt, because it is not a circular coil, okay? It is a solenoid. Understood? Yeah. So now E is equal to minus d by dt of B into A, right? B into A. B is the magnetic field due to the solenoid, right? A is area of the cross section, right? Okay. So now E is equal to minus A into B is magnetic field due to the solenoid, that is mu naught N into I, right? So now d by dt of mu naught small n into I, that is capital N divided by L into I. Mu naught N divided by L is constant. So E equal to minus A mu naught N divided by L into di by dt. So minus di by dt is minus 2 divided by 10 to the power minus 3. Sorry, here minus di is 2. Okay, not minus 2. Minus di is 2. So now E equal to A is 20 centimeter square. So 20 into 10 to the power minus 4. Mu naught is 4 pi into 10 to the power minus 7 into N is 400 divided by L. L is 20 into 10 to the power minus 2 into di by dt, that is 2 minus di by dt, that is 2 divided by 10 to the power minus 3, that is 2 into 10 to the power 3. So now solve this, you will get E equal to 4 volt. The correct option is B. Next question, question number 44. A rod of length L rotates with a uniform angular velocity omega about an axis passing through its middle point but normal to its length. Okay, middle point but normal to its length, right? So this is the rod. Okay, so this is the middle point of the rod. So axis passing through the middle point of the rod, right? Like this, and normal to the length of the rod. So now it is rotating like this with angular velocity omega. Okay, normal to its length in a uniform magnetic field of induction B. Okay, magnetic field is B with its direction parallel to the axis of the rotation. Okay, parallel to the axis of the rotation. So this is the direction of the magnetic field. Okay, the induced EMF between the two ends of the rod. Okay, we need to find induced EMF between the two ends of the rod. Sometimes they can ask what is the potential difference between the two ends of the rod. Okay, yeah. So now here it is rotating with the angular velocity omega, right? So definitely there will be an induced EMF, right? So it is a continuous system, right? So here linear velocity of this part, okay, or end of the rod is greater than linear velocity of the particle of small length of the rod which is near to the axis of the rotation, right? So linear velocity is different, right? Induced EMF or motional EMF E equal to B into V into L. So V is linear velocity. So that is induced EMF depends on linear velocity. Here the linear velocity changes or linear velocity decreases as you move from end of the rod to the axis of the rod, axis of rotation of the rod, right? Okay, so now it decreases, right? So take one small element, okay, small element dx, okay, from this rod. The distance between, let x be the distance between axis of the rotation of the rod to the small element, okay. So now here we know that v equal to omega into r, right? Here r is x, so omega is same for every small element, right? So now this is the velocity v, okay. V is the velocity of the, this is the v, okay. So v equal to omega into x, right? V equal to omega into x. And what is the length of this small element? Dx, right? So now induced EMF produced in small element is dE. So dE equal to B into V is omega x into length of this small element is dx, right? So now integrate both side, right? Integration of dE is equal to integration of B omega x dx, right? So now what is the limit? Limit will be minus L by 2 to plus L by 2, right? Minus L by 2 to plus L by 2. So now solve this, you will get induced EMF as 0. The correct option is B. Okay, yeah. Question number 45. An electrical device draws 2 kilowatt power. That is 2 into 10 to the power 3 2 into 10 to the power 3 watt power, right? From AC mains voltage 223 RMS. Here VRMS, okay, VRMS is 223 volt. The current differs, lags phase by phi equal to tan inverse of minus 4 by 3 as compared to the voltage. The resistance R in the circuit. Okay, we need to find resistance R in the circuit, right? Okay, so we know that the power drawn by the electrical circuit or electrical device P equal to VRMS squared divided by Z, right? VRMS squared divided by Z. So now here Z equal to VRMS squared divided by P. P is 223. Sorry, P is 2000. Right? P is 2000. 2000. So now Z equal to 223 into 223 divided by 2000. Okay. So now 223 into 223 is 2.23 whole square into 10 to the power 4. Right? So 10 to the power 4 by 10 to the power 3 is 10. Right? Then 2.23 whole square divided by 2. So it will be almost 25. Right? So sorry, 2.5. So it is almost equal to 25. Okay. So 25 ohm. So this is the value of Z. Right? So now phi equal to tan inverse of 4 by 3. Right? Isn't it? So we know that tan phi is equal to XC minus XL divided by R. Right? XC minus XL divided by R. So that is, here this is the angle phi. Let's draw the phasor diagram. Okay, phi. and then this will be XC minus XL, right? So this is R, and here this will be Z, right? So here phi equal to tan inverse of minus 4 by 3, that is XC by XL divided by R is equal to minus 4 by 3. Sorry, minus 3 by 4, not 4 by 3, minus 3 by 4, right? So XC by XL, sorry, XC minus XL, XC minus XL is equal to minus 3 by 4 R, minus 3 by 4 R, okay? So now apply Pythagoras theorem, right? So this is the angle 90, right? Apply Pythagoras theorem. So now Z equal to 25, right? 25 square is equal to R square plus minus 3 by 4 R whole square, that is 9 divided by 16 R square, right? So now 25 squared is equal to 25 R square divided by 16. Then take square root on both sides. Then 25 equal to 5 divided by 4 R. So 5 5s are 25. So R equal to 20 ohm. So the correct option is B. Next question, question number 46. If peak voltage of an AC supply is 440 volt, then its RMS voltage. Direct question, right? Vrms is equal to V naught, that is peak voltage divided by root 2. So Vrms is equal to 440 divided by root 2, which is equal to 311.1 volt. Correct option is B. Next question, question number 47. The phase difference between the voltage and the current in the capacitor in an AC circuit. Direct question, right? Pi by 2. That's it. Okay. Question number 48. In a transformer, the transformation ratio is 0.3. That is Ns by Np is 0.3. If 220 AC is fed to the primary, that is Vp is equal to 220 volt. Then the voltage across the secondary. We need to find Vs. Again, the direct question. Here Ns by Np is equal to Vs by Vp. Right? We need to find Vs. Vs equal to Ns by Np is 0.3 into Vp is 220 volt. So now Vs is equal to 66 volt. The correct option is D. Current in the secondary coil is 66 volt. Question number 49. A semiconductor has equal electron and the hole concentration of 6 into 10 to the power 8 per meter cube. That is Ni is equal to 6 into 10 to the power 8 per meter cube. Okay, per meter cube. On doping with certain impurity, electron concentration increases to 9 into 10 to the power 12 per meter cube. So Ne is equal to 9 into 10 to the power 12 per meter cube. The new hole concentration is, okay, so when you dope the semiconductor, okay, then intrinsic semiconductor, okay, so then Ni square, that is electron and hole concentration, okay, sorry, electron concentration or hole concentration squared is equal to Ne into Nh. So now Nh is equal to Ni square divided by Ne. Nh is equal to Ni square, that is 36 into 10 to the power 16 divided by Ne. Ne is 9 into 10 to the power 12. 9 4s are 36. So Nh is equal to 4 into 10 to the power 4 per meter cube. Correct option is C. Next question, question number 50. In the circuit shown, if drift current for the diode is 20 micro ampere. So ID, that is drift current, is equal to 20 microampere. Potential difference across the diode. Okay, we need to find potential difference across the diode, right? Okay, so here this diode is reverse biased, right? This diode is reverse biased. So therefore, the current in the circuit is only drift current, right? So now potential difference across the diode Vd, right? Vd is equal to 15 ohm into 20 microampere, that is 10 to the power 6 ampere. So now Vd is equal to 300 microampere. Okay, so now potential difference across the diode, right? Potential difference across the diode is equal to 4 volt minus 4 volt minus here I into R, right? So, sorry, this is micro voltage. Okay, micro voltage, not microampere, micro voltage. 4 volt minus 300 micro volt. So now VD is approximately equal to 4 volt only. Okay, almost equal to 4 volt. So the correct option is C. Next question, question number 51. In a PN junction having depletion layer of thickness 10 to the power minus 6 meter, the potential across its 0.1 volt, potential across it is 0.1 volt, the electric field is, again the direct question, electric field V, E equal to V divided by D. V is the potential difference across the depletion layer, that is 0.1 volt. So E equal to E is 0.1 divided by D, that is 10 to the power minus 6. So this you will get 10 to the power 5 volt per meter. The correct option is C. Next question, question number 52. In an N-type semiconductor, which of the following statements are incorrect? Okay, we need to find the incorrect statement, right? Let's check each statement. Electrons are minority carriers, wrong. So the first one is correct, right? The statement is wrong, right? We need to find the incorrect statement. Okay. Holes are minority carriers, correct. And pentavalent atoms are dopants. This one is correct. So second statement is correct. We need to find the incorrect statement. Okay. So this is the incorrect statement. Incorrect. And this is the correct statement. Holes are majority carriers and trivalent. Okay. This part is correct. And trivalent atoms are dopants. Wrong. Pentavalent atoms are dopants, right? So yeah, holes are majority carriers, wrong. This one is also wrong. Okay, sorry, holes are majority carriers, not minority sorry, holes are majority carriers, right? Here this one is wrong, right? Actually in N-type, holes are minority carriers, not majority carriers. So first part of the third statement is wrong, and the second part of the third statement is also wrong. So this is incorrect statement. Third one, electrons are majority carriers, correct. And trivalent atoms are dopants, wrong. So this is incorrect statement. So three incorrect statements, right? First one, third one, and fourth one. Third one and the fourth one. So the correct option is B, right? First one, third one, and fourth one. Next question, question number 53. Which of the following is not electromagnetic wave? Okay. So gamma ray and X-ray both are electromagnetic wave, right? Gamma ray and X-ray both are electromagnetic wave. Let's see cosmic ray. Here the cosmic rays are not electromagnetic wave, right? Isn't it? Cosmic rays are here the particle which has the high energy, okay? High energy particle moving in a free space. That is the cosmic rays, okay? Okay, moving in a space, moving in a free space or space, right? The particles are protons. So option A is correct. Right? Let's see option B, beta rays. Beta rays are high energy electron moving with the relativistic speed, right? So these two are not electromagnetic waves, right? So option A and C are correct. Option B and D are wrong. Okay, A and C both are correct. If you take A, you will get the answer. You will get the marks. If you take C, you will get the marks. Okay. Question number 54. An object placed 40 centimeter from the concave mirror of focal length 20 centimeter. The image formed is. Okay, so this is the concave mirror. Focal length of the concave mirror is 20 centimeter. Okay, and object placed at 40 centimeter from the concave mirror, right? So this is F, right? F. So this will be 2F, right? So object distance is 2F, right? If you placed the object at 2F or the radius of curvature of the concave mirror, then image will form at the 2f only, right? Image will form at the 2f only, and the size of the image is same as size of the object. Okay, so here the image formed is real. Okay, this image is real, inverted, same size, same size, and v equal to u. Okay, v equal to u. So the correct option is here A, real, inverted, and same in size. Next question, question number 55. An eye specialist prescribes spectacles having a combination of convex lens of focal length 40 centimeter in contact with the concave lens of focal length 25 centimeter. The power of this lens combination is, let us find the combination of the focal length of the lens. Okay, that is 1 by f equal to 1 by f1 plus 1 by f2. F1 is the focal length of the convex lens, f2 is focal length of the concave lens. So now 1 by f is equal to 1 divided by f1, that is 40, 1 by 40 minus 1 divided by 25. 1 by f equal to 3 divided by 200. So this is the power of the lens, right? Power is power of the combination of the lens, right? Power of the combination of the lens, isn't it? So which is equal to here minus 3 by 200. Okay, this is minus 3 by 200. So this is the power of the combination of the lens. So here, which is equal to minus 1.5 diopter. The correct option is B. Correct option is B. Question number 56. The angle of minimum deviation for prism of prism angle pi by 3 is pi by 6. So A equal to pi by 3. Angle of minimum deviation is pi by 6. If the velocity of the light in vacuum is 3 into 10 to the power 8 meter per second, then the velocity of the light in the material of the prism. Simple one, right? First find the refractive index of the material, then we can easily find the velocity of the light in the material of the prism. So mu equal to, that is refractive index of the prism, is equal to sine of A plus delta m divided by 2 whole divided by sine of A by 2. So now mu is equal to sine of pi by 3 is 60 degree, pi by 6 is 30 degree. So 60 plus 30 is 90. So 90 by 2 is 45. So this is equal to pi by 4 divided by sine of here A is pi by 3, right? Pi by 3 by 2, that is pi by 6. So now mu is equal to sine pi by 4 is 1 by root 2 and sine pi by 6 is 1 by 2. So mu equal to root 2. We know that refractive index is the ratio of the velocity of the light in vacuum to the velocity of the light in medium. So now V is equal to C divided by mu, right? So now V is equal to, C is 3 into 10 to the power 8 meter per second divided by mu is root 2. So now solve this, you will get V equal to 2.12 into 10 to the power 8 meter per second. So the correct option is A. Next question, question number 57. In Young's double slit experiment, the ratio of the intensity of the maxima and minima in the interference experiment is 25:9. The ratio of the widths of two slits is, we know that intensity of the light wave is directly proportional to width of the slit, right? In the question, they have given I max by I minimum is equal to 25 divided by 9. So I max is root of I1 divided by root of I2 plus 1 whole square. Whole divided by I minimum is root of I1 divided by I2 minus 1 whole square equal to 25 divided by 9. Right? Okay. So now take square root on both sides. So now root of I1 divided by I2 plus 1 divided by root of I1 by I2 minus 1 is equal to 5 divided by 3. Now 3 into root of I1 by I2 plus 3 is equal to 5 into root of I1 by I2 minus 5. Now 2 into root of I1 by I2 is equal to 8. So 2 fours are 8. Finally, the ratio I1 divided by I2 is equal to 16 divided by 1, which is equal to W1 by W2. This is the ratio of the width of two slits, 16 is to 1. The correct option is D. Next one, question number 58. Instead of using two slits, if we use two separate identical sodium lamps in Young's experiment, which of the following will occur? Okay, instead of using the instead of using the coherent source, okay, if you use two identical sodium lamps or two identical light, so we don't get the maxima, okay, or we don't get the bright fringe, we will get dark fringe, right? Why? Because in coherent source we have, okay, in coherent source has same phase frequency, right? Same phase frequency and wavelength, right? But in identical sources does not have uh, same frequency, wavelength and phase, right? So we will not get same frequency, wavelength and phase. So that's why we are not going to get the bright fringe, we will get dark fringe. So the correct option is D, very dark minimum. Next question, question number 59. Wavefront is locus of all points where the particles of the medium vibrate with the same phase. Same phase. Huygens wave theory, right? The correct option is A. Next question and the last one. The resolving power of the telescope increases with. Here the resolving power RP of the telescope is A divided by 1.22 lambda, right? So A is the aperture of the objective, right? If you increase the diameter of the objective, we will get the more resolving power, or the resolving power of the telescope increases. So we have to increase the diameter of the objective, okay, or aperture of the objective. So the correct option is D. And thank you so much for watching this video. Okay, if you love this video, please like and share, and if you want to watch more such videos, please subscribe. Thank you.